Alright, so I did mention in my previous video that I'm going to be doing another one. So what we have here is the binary tree for post-order traversal. My previous video is pre-order, and I also have done the in-order one. So this one's going to be on post-order. Alright, so 145 binary tree post-order traversal. Given the root of a binary tree, return the post-order traversal of its own node's value. So post order is basically the last DFS where it does the left right to node. So I'm gonna write it out again. In order is left node right. Pre-order is node left right, and then post order is left right node. You can kind of see that like most of them has like the left at the very first, except for pre-order. But even pre-order is like you're just adding the node in before you move to the left. So there's that. So for the post order, we're doing the left right node. Okay, so basically the concept for it is for each node n, post order will traverse the left subtree first, and then traverse the right subtree, and then visit the node itself afterward. All right, let's write the code. Okay, so again, same thing. LeetCode gave us the definition for the binary tree node. What we're gonna do again is gonna be importing Java array list. I'm gonna import Java list. Afterward, within here, I wanna create the list integer. Result is going to be new array list. Afterward, now this time I'm going to, well, again, same thing. I'm going to be writing a helper function. So post order helper with the tree node list integer result. Again, base case, if node is equal to null, just return it. Now this time it's gonna call itself with the node.left and then result. Afterward, it wants to call itself again for node.right and then result. And then at the very end, you want to do result.add for the node value. I'll write down the comment real quick. So traverse left subtree, traverse right subtree, visit current node, and oh, I forgot about this part. Post, we want to call it post order helper, put in the root from here, in the result, and then just return result. That's it. So once again, I'll explain the lines. What we have here is so post order traversal is the main function that the LeetCode is going to call. The result will store the values in post order sequence. We call the helper starting at root, and then return after the recursion finish. So we want to return the result, the completed list. Now what we have here is node is the current node. If node is empty or null, that means there's nothing to traverse, so just return immediately. We're gonna first recursively process the left subtree, so afterward recursion for the right subtree, and then finally, once you're done, you visit this node by adding its value to result. So that the order is gonna be left right node, and that's basically post order. Let's run it to make sure there is no error. Perfect, all case pass, submit. And all right, perfect, that's everything. So once again, I'll show an example of it, of how it goes, I guess. So you want to first start at let's see. Yeah, so you have result being empty right now, and then you have the post order helper with root being 1, and then the result. So now we're gonna, once we're inside here, we're gonna look at the post order helper 1.left. As you can kind of see, 1.left is null. So if the node is null, we skip it. Now we check the 1.right. 1.right is 2. So we're gonna now change it into post order for 2. Post order helper for 2. Now that we're on 2, we want to again do the recursion. Post order helper 2.left. Anything for the left? Yes, there is, and it's 3. So once it's 3, now we change it to 3. Now we're gonna do 3.left. Is there anything? No. Node is null. Return it. Let's check the right. Is there anything? Also no. So node is no again. So again, we're gonna skip it, and it makes sense because 3 is the leaf, right? So now we want to add the value. So the result becomes 3. Afterward, we go back to 2. Now, since we finished the 2.left, we're doing the 2.right. Is there anything for the right? No. So again, node is null. So once we skip, and then we add. Now, once 2 is done, we go back to 1. 1 already did its left, and 1 just finished its right. So when that happens, then we just add the value. So this will become the result, just like the output right there. And that's it. So, and that's basically how you do it. And now I'll quickly talk about the complexity. So once again, let n be the number of nodes. If we do time is big O of n because we are visiting each node once. And then we have space being big O of n as well because we are adding all the value into the space. So that is pretty much it. Now I have completed basically all 3 of the traversal. Oops. Okay, there we go. So here's the post order. As you see, it's left, right, and then you add the value or visit. If I go here and we look at the left, or we look at the pre-order, we have add, left, and then right. So same thing, and then if I go all the way up here, it is in order, which shows left, node, right. And that is it. Yeah, all the codes are basically the same thing. All you're doing is you're changing the calls. All right, thanks for watching.